Hello friends, today we will discuss about the RNS configuration, and this RNS configuration is from the last chapter stereochemistry, and this stereochemistry chapter belongs to F.Y.B.Sc paper 2nd, that is organic chemistry. Now RNS nomenclature system is the naming system for optically active compound, and this is developed by the scientist Chan, Ingold and Prelog in 1966, and hence the rule is developed by this Chan, Ingold and Prelog is called as CIP rules. CIP rules, and with the help of these CIP rules we can decide whether any particular chiral compound or optically active compound is R or S. Okay, and with the help of these CIP rules, there are two steps. Step first and step second. In step first, we decide the priority of the substituents which is attached to chiral center. Suppose you consider the representative example here. Suppose here A, B, C and D. Then with the help of these CIP selection rules, we decide which one having the more prior or second prior, third prior or last priority. Means step first consider the priority of substituents, and in step second we assign the optically active compound whether R or S. For this we arrange these substituents like this way. The highest priority groups are arranged at the top, and lowest priority group is arranged bottom of this group, and we can make the even changes for arrangement of this highest priority group at the top and lowest priority group at the bottom. And after this we can decide, suppose here top priority group is present here, then second priority group is present here, third priority group is present here, and fourth one. But at the time of assigning R or S, we ignore this fourth one, lowest priority groups, and only consider the 1, 2, 3. Suppose we ignore this fourth group and we start the arrow from first, second and third. Whether it is clockwise, then it is R, and suppose it is anti-clockwise, then this is yes. Again we will remind this one. There are two steps, step first and step second. In step first of all we decide the priority of substituents. You know very well about this. This is chiral center, and here A, B, C and D. means different groups or atoms are attached to this chiral center, and in step first we decide the priority of these substituents. Deciding the priority of this substituent is like the sequence rule which is used in the EZ configuration. Now what happens in case of step second? Actually step second is related to the assign the optical active compound R or S. But before assigning this R and S configuration, we arrange these four groups like this way. Highest group is present or arranged at the top here, and lowest priority group is arranged at the bottom here. And for the changes, we interchanges even way. Even means 2 times, 4 times or 6 times, not odd number. Okay. After arranging highest group at top position and lowest group at bottom position, then we will assign this RNS configuration. At the time of assigning this RNS configuration, we ignore the fourth group because these lowest priority groups are present backside of the paper or backside of the board. Then, and here fourth group, suppose it is backside of the paper or backside of the board, then there are 1, 2 and 3, only 3 groups are present, and we assume or we start the circle arrow here from the 1, 2 and 3, and hence this is clockwise, and when it is clockwise it is R configuration. Now here suppose these groups are like this way 1, 2, 3, but it is anti-clockwise, then it is yes. Okay. Now on the basis of this we discuss the example for this. Now for this we take the example of lactic acid. Lactic acid. Suppose your question, assign RNS configuration for following compound or lactic acid. Now here this is the lactic acid. Okay. Now we will take the steps with the help of CIP rules. Now step first, what is the step first? Step first is the deciding the priority. Now here this is chiral center, and 4 groups are attached here: CS3, OH, CWH and EH. And at the time of deciding the priority here, first of all we consider the atomic number. Now here the OH is having the highest priority, then CWH, then CS3 and EH. Now why this is such arrangement here or such priority? Because oxygen having the atomic number 8, this carbon having the atomic number 6, this having the 6 and this having the 1. There are no doubt OH is having the highest priority because the atomic number is 8, and hydrogen is having the lowest priority because it having the atomic number 1. Now there are tie in between this CWH and CS3, but in case of CWH we apply the second sequence rule, that is next atom. In case of CWH here actually we consider this way: and when we count the total number, there are 24 is the sum of this atomic number 24, and here only 6, and that's why this COO is having the second priority and CS3 having the third priority. So these having the first priority, these having the second priority, these having the third priority, and these having the fourth priority. Means as per the CIP rules, this is the step first, and on the basis of this step first, OH having the first priority, carboxylic acid group having the second priority, CS3 having the third priority, and EH having the fourth priority. Now we will move towards the second step. Okay. In step second, here we have to arrange this group like this way. OH group at the top position and EH group should be at bottom position, and we make the even interchanges. Okay, so we make the even interchanges for arranging OH at top position and EH at lowest position. Okay, now we will take the original compound CS3. Okay, so here first interchange in between OH and COOH, and then see here OH here, then COOH here, remaining two are as it is. Okay, now OH at the top position, then we will make the second interchange in between H and CS3. Okay, then OH and COOH as it is, CS3 is here and EH is here, and you know very well about this. In this step, H should be ignored. It should be ignored because it at the back side position, and here OH having the first priority. You know very well about this first priority. COOH having the second priority and CS3 having the third priority. Now this is the time to decide whether it is R or S, and here we start the arrow from first, then second and third. Okay, and this arrow is moving clockwise, so this compound having the R configuration, Okay, now we will see one more example. Okay, we will do second example. Example second. Okay, now as per the CIP rule, step first is for the deciding priority groups. Now here atomic number is 8 here 6 and 1. No doubt OH having the highest priority, and EH having the lowest priority. Now here we decide the priority in between COOH and CH2H. Now you know very well about this. We consider the second sequence rule. Next atom, after carbon atom there are oxygen, and there are 2 oxygen, and after carbon there are H and OH. So COOH having the second priority and CH2OH having the third priority. Okay, means here this first priority, this is second priority, this is third priority and fourth priority. Okay, now we arrange these substituents like this way. This OH group should be arranged at top position and H should be at bottom position, and for this we take the even interchanges. One thing is clear here, for the arrange the highest priority group at top and lowest priority group at bottom, you should be take the even interchanges only, not odd. Okay, now we take our original compound here, COOH, H, CH2OH and OH. Okay, now first interchange, in between OH and COOH. Why? Because we want to move this OH at the top position. Okay, now here this is OH here, then COOH here, H as it is, and CH2OH is also as it is. Okay, now second interchange. Okay, second interchange in between H and CH2H. Why? Because we want to move this H at the bottom position. So H and CH2H, and we make only 2 interchanges. There are only even interchanges are allowed. Even interchanges means 2 times or 4 times. Okay, not 3 times. Okay, now here after interchanging this H and CH2H, we obtain this structure. This is chiral center. Now this H is ignore here. Okay, means H is present at the back side of this board or plane of the paper, and this is the priority. No, here second and this one is third. Okay, now we move 1, 2 and 3. Again see here 1, then 2 and 3, and when we see this one, this is like a anti-clockwise. This is anti-clockwise. So this is S configuration. This is S configuration. Okay. One thing is, remember here again, here step first is also important, because deciding the priority of the groups is very important. Then in step second, we arrange the atoms or that groups which is attached to that chiral center like this way. At the top there are highest priority groups are arranged, and at the bottom there are lowest priority group are arranged. Okay, and for the arranging the highest priority group at top and lowest priority group at bottom, we do the interchanges, but the number of interchanges, it should be even. Number of interchanges, it should be even number. Like this way, in this example, we interchanges 2 times, and this 2 number is even number. Okay, now again we will take one example, last one. And H. Okay, now step first. In step first, we decide the priority of that particular atoms. Okay, now in this case, bromine having the highest priority, then chlorine, then COOH, and last H. Why this bromine having the highest priority? Because the atomic number of this bromine is 35, and this chlorine having the atomic number 17, the carbon having the atomic number 6, and hydrogen having the atomic number 1. I repeat these steps. Here bromine having the highest priority because it having the 35 atomic number, chlorine having the 17 atomic number, and carbon having the 6 atomic number, and hydrogen having the 1 atomic number. So bromine, then chlorine, then COOH, and then EH. Okay, then step second. In step second, we arrange these substituents like this way. This Br should be come at top position, and hydrogen is arranged at bottom position. For arranging this Br at top and hydrogen at bottom, we make the even interchanges. Okay, now we will write here original compound, chlorine, H, COOH, and Br. Okay, now first interchange. First interchange in between Br and chlorine. Why? Because we want to give the position of Br at the top position. Okay, so after interchanges, Br at top position, then Cl, then COOH, and EH. Okay, now here H already come here, H at bottom position, Br at top position, but one thing is remember here there are only one interchange takes place, and at the CIP on the basis of this CIP rules, you must having the even interchanges. So we should be do here second interchange compulsory here, because interchanges should be even number. So second interchange in between chlorine and COOH, in between chlorine and COOH, it is only for doing the even interchanges. So here Br, H, and carboxylic group, and Cl. Now you know very well about this. This hydrogen at the back side position, ignore it. Then write down the priority of this group Br, then the second and third. Now 1, it should be start from 1, 2, and 3. Now when we see this arrow, this is clockwise, so this should be R configuration. Okay, I took here one example here because in this case already we obtained the Br at top position, H as bottom position, but we should be do the even interchange. So the second interchange is compulsory, okay, and hence we do the interchange in between chlorine and COH, and this having the R configuration. Okay, thank you.